Good evening, Gauri. I mean, good evening to everyone. Okay, so we are meeting after a few days, right? We last met on, if I'm not wrong, we met on Friday, isn't it? We met on Friday. Then we are meeting today. That means after Saturday, Sunday, Monday, Tuesday. Today is Wednesday. So there is a few days of gap. Hope you people are still connected. Okay. So today what we are going to discuss is a chapter sound. So for the previous two chapters that might have already completed in your school while when I was teaching you people. But in case of this might be an ongoing chapter or else it could not means it might not have started in your school. So please listen carefully and we will go in detail in this chapter. Okay. Is there anyone's in is there means is this chapter started in your school? I mean, anyone is not familiar with this chapter, it is not started in your class. Anyone? No, it started. Okay, somebody was having exams last week. Did you receive your papers? I remember Gauri or Bhavya. Somebody told me that it was exams. Did you receive your papers? No. Okay. Okay, we are good to go. So let's start with the chapter. So as usual, if you have any doubt, you can put that in the chat box or you can put it that in the Q&As or something. So I can have a look on it and I will be able to clear your doubts also. This is our last session. That means this is our last session that we are going to be together. So let's make our last class memorable and let's make it much interesting. Okay. So the chapter which we are going to do is sound. Hmm? Let's examine ourselves. I'm speaking to you people and you are putting the messages in the chat box. I'm not enabling you to speak, isn't it? I have unmuted each and every one of you and I'm not making you people speak. I'm the only speaker and I'm delivering it, isn't it? So I'm speaking and the sound is being propagated. I'm using a mic over here to get a much amplified sound so that it reaches without any loss up to you people, isn't it? And you are actually hearing that with your ears. So if we are going into detail, see, I'm producing the sound from my throat, isn't it? If I'm going to say, I'm not making any sound, like I'm just giving my lip movement. So unless if I'm not using my vocal cord, unless if I'm not making any vibrations in my throat, the sound will not be produced. Correct? Same way, the whatever you see around you, let it be a musical instrument or let it be the school bell which is there, or a few of you will be having a pendulum clock at your home, isn't it? Because our class is scheduled at 6 o'clock and you people came to know somebody means if you could have kept an alarm, so the mobile got vibrated or it gave you a ring, so you remember, oh, it's 6 o'clock, we do have a physics class, right? Then you came for the class. Somebody would have a pendulum clock over there which will make sounds, tick sounds when there's a six. I mean, it will. What's the specialty of the pendulum clock? Pendulum clock will make 6 full swing sounds for the 6 o'clock and 7 full swing sound for 7 o'clock and all the half time. That is 7:30, 6:30, everything. It will make a very different kind of sound, isn't it? So that's how we came to know that, oh, now it's 6 o'clock, nearly it's being 6, we have class, right? And when you open the laptop, you means laptop or mobile phone, you opened it, there was some sound when you touch the keypad. Sometimes you might have kept that off also. But when you unlock the mobile phone, there's a slight sound which is coming up. So when you look all around, sounds are there. Now you people might be sitting in a room, keeping your fans on, right? Your fans are on, right? And you people can hear the sound of the fan. Suddenly, if it starts raining, then also you will be able to hear it if your windows are If not also, if windows are not open also, when the raindrops fall on the roof, you will hear some sound, isn't it? So imagine if you are not able to hear anything. Okay, if such situations were there, you are not able to you are not able to hear anything, or you have some disability by which you are not able to hear properly. Okay, imagine things would have been much difficult, right? Very difficult, isn't it? Because you people won't be able to enjoy music. Music is something everyone loves, isn't it? For me, if I'm particularly saying, if I'm stressed out and if I'm in a very bad mood, I used to listen to some kind of music so that I get calm, and I enjoy music also. If you plan a picnic, good evening. Yeah. If you plan a picnic also, means you people will be putting some high bass music on the bus and you will be dancing it off, isn't it? Catching all the beats. So music is something which adds color to our life. Same way we can say that music is because of the sound only. Sound makes it much more colorful. Okay, you are able to, when your father gives you a call and it's not, your father's name is not saved in the phone, then also you will be able to understand his voice because you are very familiar to it. Because each and every person will have a different voice. Yes, we can mimic them, that's a different thing. I'm not speaking about that. But each and we are able to actually distinguish between people with their sounds also, by the way they talk, by the sound they produce, etc., isn't it? So sound is something which we, okay, that's fine, Udiba. I got your message. Okay. So sound is something which we encounter in our daily life, but there are certain aspects of sound which we know that it exists, but we don't know why it exists. For example, if I'm making, let me say, if I'm making Adraj, can you say a hello to all? Adraj, you have the ability to speak. I have made you unmute. Could you say hello?
Hello.
Hello. Okay. Now let me ask Bhavya. Could you say hello? Bhavya, are you there? Oh, she. Oh, I didn't give you the permission. 1 second. Yeah, one. Okay. Can you say hello?
Hello, ma'am.
Okay. So when I heard the voice of Adraj as well as when I heard the voice of Bhavya, you people might be hearing, you people also heard it, right? Both of them are having a very different sound, isn't it? For some, I don't know in which perspective, but both of them actually give sound in a different way, right? So today we will discuss what makes it different, as well as we will discuss some interesting facts about sound. Okay. So in the previous slide, you might have seen a lot of musical instruments on here, right? One as a violin, a drums is given, harmonium is given, a piano is given, a trumpet is given. A lot of musical instruments are there. See, musical instruments also make sound off with the same phenomenon by which we are making the sound, isn't it? The basic cause of sound is due to vibration. Okay. If my videos are on, right? Okay. Yeah. 1 minute. Give me a second. Some trouble. Okay. Fine. I had given permission to Amran, but I didn't make him speak. Okay. So if I'm actually taking a pen, I have taken a pen in my hand. I'm just making some sound. See? Okay. As well as I'm taking something else. Okay. I do have only a mouse with my hand right now. I'm trying to make it sound. See, when I'm making it, what is happening there? There is some sort of vibrations happening. Okay, there is some sort of vibrations happening. So with this vibration only, the sound is produced. Okay, so the first figure which is shown on the screen is a tuning fork. Tuning fork, it will have different frequencies. That means That uniform we will get for different frequency. We will discuss later on what do you mean by frequencies are. We will get a uniform for 230. We will get a uniform for 110 hertz. We will get a uniform for 50 hertz. The specialty of uniform is that we will be able to detect the vibrations very clearly using a uniform. So if you tap it, then you will be able to see the vibrations as well as we will be able to hear the sound. For example, to understand the concept of vibration, if you are having a rubber band in your hand, imagine that you are having a rubber band in your hand. And if you pluck it once, you will see a movement. If you do it twice and leave it, for some time, the vibration will persist. So vibration is the means by which we are able to make sound. Okay. That is applicable for each and every case. That means if you are considering the school bell in your school, that also makes sound due to the vibration. When the metal shown over here comes in contact with the metal body, when it strikes over there, what will happen? These both vibrate. When this metal strikes on the metal surface, the metal actually starts to vibrate. Due to this vibration only, what is forming? The sound is being produced. Okay, so sound is actually produced by the vibration of the body. Clear this much? Any doubt? Okay. Okay, so let's go on. So we will think about we will discuss about the musical instruments and their vibrating part producing it. For example, I'm taking a veena. So veena is whenever we are playing the instrument veena, you might have not played it, but you have seen people playing it, isn't it? So it is a membrane. It is not the membrane. It is a string which is actually vibrating there. So the string produces vibrations so that what happens? The sound is produced. But it is not only the string which is vibrating. When the string is made into a vibrating mode, the whole body also starts to vibrate. That's a different thing. But here we can say that the vibrating part which produces that sound is the veena. Sorry, is the string. Okay. When it comes to tabla, it is a membrane which is vibrating. There is an outer membrane whose thickness depends the characteristics of the sound produced, the material by which is just made, as well as the thickness of that membrane, etc., and how hard we strike on it, at which position we are striking. All those decides the kind of sound it is producing. Okay, if I'm saying you guitar, can anyone say which is a vibrating part of a guitar? Anyone? You can put in the chat box. I can read from there. Okay. So in case of guitar also, the vibration is due to which one? The string. Okay. Now you might have seen cymbal or manjira, which is usually seen in the whenever there is a chendamelam or something, there will be people using this manjira, which is actually two flat surfaces, and by striking it, it will make the sound. Okay, so that also makes the sound by the vibration of the metal surface, right? As well as you might have seen khadam. Khadam is simply, 1 second. Khadam is simply a clay pot, which is kept in the reverse model. Okay, and earthen a clay pot only, but it is kept in the inverted position, not like the open end. Not like the open end is kept in the erect position. No, not like that. The khadam is kept reverse, that is open end will face us, and the other part will be infrared, and we will be striking on it to make it noise. This can be examined by doing, if you itself, I mean everybody will be having an earthen pot at your homes, isn't it? So when you tap on it, different sounds are made. So depending on the material or the quality of the material by which it is made, and the part at which we are making the vibrations, the sound is produced. So in case of khadam, the vibrating part is the clay pot, means the clay surface of the clay pot. Okay, that's the vibrating part. Now if I'm asking you violin also, the vibrating part is what? String only. But for violin also, the vibrating part is a string. Now what about chenda? Any idea? Chenda. Okay, Gauri plays guitar. Do you? Okay, I would like to hear some melodious voice after this class. Huh? Okay, so what about chenda? Chenda is the membrane is being being vibrating. Okay, so in case of chenda, the membrane gets vibrated. So in case of flute, we can say, or trumpet, we can say, in all of these cases, the vibration is of the air column. Okay, when we actually play flute, we actually adjust the which one adjust the air holes of the flute so that the vibration of the air column differs. So difference in the air column actually creates a sound. Okay, clear this much? So we came to the conclusion that all of the sounds are produced due to vibration, which in case of musical instruments, okay, that's fine. Okay, okay, so your message. I will not make you play guitar. Let's see something else. Okay, so after this, okay, so we have gone through, we had a look on the musical instrument, same as when we are speaking also. The sound is actually produced by the vibration over here. Okay, could anyone say which is the part vibrating here to make the sound produced? Anyone? When you touch, you can examine now itself, you can touch your throat here. When you speak, there is something which is being vibrated. There is something which is being moving there. What is that? You can touch it and see. There is a bump-like structure also. What is this called? Yeah, this is the vocal cord, which is also known as Adam apple is a bulge. Okay. So we do have a voice box over here, which is also known as the larynx. Okay. So this voice box or the larynx vibrates if when we act, means due to the vibration of the voice box or the larynx only, we are able to make sound. Okay. And the bump, as you said, it is the above portion of the windpipe. Okay. So the vocal cords are on the two sides of this. So vocal cords actually change there. We can say that it stretches and it relaxes depending on the kind we are speaking. Okay. For example, if I'm going to shout very high, that means the vocal cords are completely open as shown in this figure. If I'm going to speak very calmly, then that is depicted in the first figure. And in second figure, if I'm going to keep shut, I'm not going to utter any word at all, then means this is the position of the vocal cords, that it will be completely relaxed. And if I'm very speaking in very less voice, that means if I'm whispering, then the vocal cord will be something like this. Okay, so depending on the thickness, means depending on the stretchability, or we can say that the thickness of, not the thickness, how much it stretches and relaxes while we speak, the sound also different. So it is different for calm speaking, it is different for when we speak silent, it is different for when we speak it very loud, and it's different for when we whisper also. Okay. Devabala. Devabala, I'm seeing you for the first time. I don't think that I had you in the previous two classes. Were you there? Okay, let me just go through the names. Is the no ma'am, first turn. You okay? First turn in your class. Okay, welcome, Devabala. That's what I didn't notice you in the last two classes. That's what. Now, April, Shalu, Adrich, Akshat, Amrin, these people. Okay. Aromal, Sita, Kunnel, Kuriel, Babya, Sipya, Devabala, Flora, Gauri, John, Elto, Kartika, Dushin, Shindy, Utiva. Aromal, were you there last class? Were you there, Aromal? Or are you attending the session for the first time? Okay, so what did we learn now? We learned that sound is produced due to the vibration. Okay, fine. Okay, I saw your messages. So sound is produced due to the vibration of objects. In our case also, it is due to the vibration of a larynx. Sound is being produced, and according to the position of the vocal comments, while we are speaking in different kinds of speaking, such as when we I'm sorry. Whenever we are speaking calm, whenever we are speaking loud, whenever we whisper, the position of the vocal cord, not the position, the way by which the vocal cord stretches differs. That makes a difference while we are speaking. Okay, clear this much? Can we move further? Very small chapter and very that's okay, Roman. That's fine. It happens to everyone. The net connectivity is very bad sometimes. Okay. Now imagine you are locked in a room. The entire windows are closed, entire doors are closed, and there is no proper ventilation also. You are screaming, you are crying very loud. Will anybody hear your voice? Will anybody hear your voice? No, no. Okay, you can examine the situation which is given in the figure also. You are there in the car, locked. Okay, nobody is outside. Okay, there is no means windows are locked, the doors are locked, everything is completely locked. You tried screaming for a great time, but nobody hear you. Could you anyone say why? In both of these cases, sound is not audible for any other persons who is outside that particular closed area. Why? If you are going to, your parents might be saying that don't sit alone in your room, don't lock yourself, because if you are making sound also, they won't be able to hear you people, isn't it? Yeah, sound waves cannot travel in vacuum. That means sound actually requires a medium for propagation. It requires some medium. If you open the windows, then yes, then you will be able, the sound will be able to travel and it will be able to reach others' ears. But if it is entirely closed and if there is no medium inside, then sound waves will not travel at all. That means there is no mode of propagation. So sound requires a medium for propagation. Okay, it will not, sound waves cannot travel in vacuum. So it requires a medium for its propagation. So my next question is, can sound waves move? I mean, what about in liquids? Can sound waves travel in liquids? Is that possible? Imagine that you people are having a beaker and it is filled with water. We can say that keep a bell inside. Don't put your mobile phone to check it out. Keep a bell inside and make it vibrate. Switch it on. Will you be able to hear the sound of the bell? You will be, right? You will be able to hear the sound of the bell, which ensures that sound can actually travel through liquid. What about in solids? For example, if you might be sitting on a desk right now, or you might be sitting on a table, lay down for some, not, don't sleep, lay down just for 2 minutes, keep your ears very close to the desk and tap on the desk making sound. Just tap it. You are hearing the sound reaching your ears, isn't it? You are able to, as well as when one person is sitting on the one corner of the bench and another one sitting on the another corner of the desk also, at that time also you will be able to hear the sound. Why? Because sound is actually traveling through that particular surface. That means sound is actually traveling through the solid. You might have done this in smaller classes using paper glasses or something, which, or matchstick or something, by connecting two match boxes on other ends, and you will try a string across. Okay, make one person stand on one side of the wall and another person on the another side of the wall. Okay, and if you speak through it, if you speak through that match box, means not the if you speak through that paper glass, or if you speak through the matchbox also, the other person will be able to hear you people. Why? Because sound can actually travel through string also. Okay, so sound waves can travel through solids, it can travel through liquid, as well as it can travel through gases. Okay, so it requires a medium for propagation, but they can travel through all of the three mediums of matter. Clear? Any doubt till here? Any doubt till here? Yeah, no doubt. Okay. All okay. How's your classes going? I mean, let me ask a few things. Today it might be 50%, not a 50. I think 70 to 80% of classes have whatever we have scheduled had occurred and you people had attended it also. So how's the overall classes? All well? You were able to understand everything? Different subjects. Okay. Okay, fine. I got a few replies. Okay, by the end of the session, we will speak a little time. We will take some time and we will connect to each other so that we all of us will feel better, right? So let us quickly finish it off. Quickly, we will just try to finish off this chapter and we will have some quality time together. Okay, so till this moment, we were speaking about the way by which sound is produced, how the vocal cords produce sound, how our throat means, how musical instrument produces sound, isn't it? Now, how does we hear the sound? We are able to hear the sound through ears, right? So I'm sorry, ears contain a very stretchable membrane known as eardrum, which is shown over here. This is the eardrum. Okay. When some mechanical sound reaches the ear, that means when it reaches the eardrums actually starts to vibrate. This you can examine by, for example, if you're taking a balloon, okay, not a complete, yeah, take a balloon and just tie it over on an open beaker. Okay, take a beaker and we are tying this balloon over the mouth of the beaker. Okay, now try to make some sound by tapping on this membrane. What will happen? The membrane will actually vibrate, isn't it? The membrane will start to vibrate. So when actually the mechanical sound waves reach the eardrum, the eardrum will start to vibrate, which is then carried out to the inner ear, and from it is converted to signals. Then only we are able to hear sound. Okay, imagine whenever we are speaking, we are hearing at the same time, right? So imagine how fast this process is taking place. Okay, that's a very quick thing. That's a very quick thing which is happening. Arumal, you raise the hand. Is there any doubt you are having? Okay, continuing with the class. So eardrum actually vibrates whenever. Oh, now you are able to hear me, right? Okay, so whenever a mechanical sound wave reaches our ear, what happens to the eardrum? Eardrum will start to vibrate because it is a structured membrane. So this will actually start to vibrate and this is then carried out to the inner ear. Okay, this is actually carried out to the inner ear and then the signals are produced and then only we are able to hear the voice. Okay, can anyone say any feature regarding this stapes? What is the speciality of stapes? There are three bonds in our ear, which is incus, stapes, and malleus. What is the speciality of stapes? Anyone? What is the speciality of stapes? Let us check the. Okay, somebody reply to me. Does anyone else knows? Okay. Okay, so remember that is the smallest bone in human body, which is there in the ear, which is there in the middle ear. So in middle ear can be divided into three. Actually, it is out of your context that it can be middle ear, outer ear, and inner ear. So middle ear actually contains three bonds, which is incus, malleus, and stapes. Out of that, stapes is the smallest bone in the human body. Okay. That's very important. Means it's a GK question which is usually asked, which is the smallest bone in human body. Okay, so stapes is the smallest bone in human body. So this much is clear, no? That sound is being produced that we came to know, as well as we learn the method, means learn the propagation of sound, how sound propagates from one medium to another, and by what all medium, through which all medium the sound propagates. That also we covered. Then we discussed about we don't have to study in detail regarding the structure of the ear. We have to only focus on the eardrum. So it is the eardrum which vibrates when a mechanical sound wave is falling on it, and the inner ear actually carries it forward, and signals are produced, and then we are able to hear the sound. Okay, I hope this much is clear to everyone. Okay, fine. Now, frequency and amplitude. There are certain characteristics of sound. Whenever we say a sound wave, sound as a wave, okay? So frequency is simply, we know what is an oscillation is, isn't it? Okay. Imagine you are swinging in a swing. Okay, you are swinging on a swing. Okay, so the number of oscillation, that is the to and fro motion. If you are going 5 times in 5 seconds, okay, that means you are moving 1 time in 1 second. This is the frequency. That is, the number of oscillations per second is actually known as the frequency. If in 1 second you are having a to and fro motion, or you are having 5 oscillations, then that means your frequency is 5. Okay, the unit of frequency is Hertz, which is represented by the letter H and Z. Okay, so that is the number of oscillations per second. That is actually known as frequency. Clear this much? The number of oscillations per second is actually known as frequency. Clear? If so, let me ask you a question. If a body undergoes a vibration 50 times in 2 seconds, okay, then what is its frequency? I want everyone to answer this question. If a body vibrates 50 times in 2 seconds, then what is its frequency? Okay, okay, I got a few answers. I want everyone to answer. Okay. Flora, I need to call some few names because otherwise I won't get reply. I think Sibya, Amrin, give me the answers, please. I didn't receive your answers. Johan, Karthika, Sarah, Srinidhi. What is the answer? If a body is vibrating 50 times in 2 seconds. Yeah, I can. I'm repeating what frequency is. Frequency is the number of oscillations or vibrations. Frequency is the number of oscillations or vibrations in 1 second. So if this body is vibrating 50 times in 2 seconds, which says that it vibrates 25 times in 1 second. Okay, which means the frequency is going to be 25 Hertz. Clear? The frequency is going to be 25 Hertz. So frequency is the number of oscillations per second. So what if I'm giving you a body is vibrating 20 times in 1 second? Then what is the frequency there? 20 vibrations in 1 second. Then what is the frequency there? Okay. Okay. Okay, fine. Now you got it, right? So frequency is the number of oscillations per second. That is actually known as a frequency. Now, what do you mean by amplitude? Amplitude, we can say that if I'm representing this in the form of, if I'm using this, I'm drawing the wave in this kind, then amplitude means a vertical displacement over here. This is the amplitude. The vertical displacement at which means the sound wave is producing is actually known as the amplitude. Okay, clear? Or else we can say that, to put in a simple words, how loud a person speaks can be interpreted in terms of amplitude. Okay, so loudness is measured in terms of amplitude. Okay, which one? Amplitude, no? Okay, amplitude you can relate in this way. Amplitude is related to loudness. Okay, I'm speaking to you people at some voice now. I'm raising the voice now. So both are having two different amplitude. So as I increase the amplitude, the loudness of the voice also increase. Okay, clear? So we can say that actually the loudness is proportional to the square of the amplitude. So if I double my amplitude, the loudness gets 4 times more. Clear now? So amplitude is the measure by which we measure the loudness of a particular voice. Clear? Okay, fine. So I think it is clear now. So when we increase the amplitude, the loudness of the voice also increases. Now let's move on to the next topic, loudness and pitch. We already discussed the loudness, isn't it? If we look at look at me itself, when I'm speaking, I am actually increasing the loudness at some point I'm not increasing at all, isn't it? So loudness is the we can say that it is a characteristics of the sound that we produce, how loud we are speaking, that is actually measured by the amplitude. Now what do you mean by pitch? I think Gauri told me that she plays guitar, right? So everyone who sings, or else if you are watching any reality show, they will be saying about pitch, high pitch and low pitch. So a few people will be able to go smoothly to high pitch. They can sing very smoothly on high pitch, but whereas in they will feel little difficult when it comes to low pitch, isn't it? So what do you mean by pitch? And another difference is that when you examine, females are having a higher pitch voice. That means it will be easier for a female to sing in a high pitch than for a male. So pitch is actually the frequency. It is actually related to the frequency. If the frequency of vibration is more, then we say that it is a high pitch voice. Okay. If the frequency of vibration is less, then we call it as a low pitch voice. So as we discussed earlier, it is due to the vibration of the larynx, the sound is produced, right? So if the frequency of that vibration is more, then that is a high pitch voice. If the vibration of that particular means that vibration is less, then that is a low pitch voice due to the difference in the vocal cords of men and female. Okay, men and women, there is a difference in the pitch of the voice. There is a difference in the thickness of the vocal cords of men and women. Hence, there is a difference in the pitch. Okay, this you can analyze when a small baby is crying. Okay, when a small baby is crying, we will get irritated at some point. Why? Because it's like it's a very high frequency voice which has a very high pitch. Okay, because why? The vibrations per second is much more when compared to that of adults. Clear this much? So we discuss about frequency, we discuss about amplitude, we discuss about loudness. We now at last we got pitch. Is this much clear? I hope this is clear. Fine. Now, we are not able to hear a certain sounds which are produced below certain frequencies and above certain frequencies. For example, our audible limit is between 20 hertz to 20 kilohertz. I hope what you mean by hertz is clear, right? Hertz actually indicates the frequency. So we are only able to hear those sounds which are between 20 hertz and 20 kilohertz, which are less than 20 hertz and which are more than 20 kilohertz are not audible to us. Human ears don't have the capability to hear such voices. Okay, such voices are termed as ultrasound, infrasound. There are many names given to that, which you need not learn now. But examination means we can easily relate that to the animals around us. For example, dogs' audibility is different from ours. Okay, they can even we will say no, they can even understand the movements of the if there is a thief outside the house, they can actually detect it. If there is a one outsider out of the house, they will be able to detect it very fast. How are they able to detect it? Because they are able to detect even minute frequency voices, even minute vibrations they are able to detect. Okay, so which indicates that the audible yeah, true, some dog whistles are also like that. So which indicates that the audible limit of humans are different from other animals. That is applicable to whales also. When it comes to bat doesn't have the ability to see properly, right? So at night, so at night, how do they catch prey? They actually uses this method, that is, we say it as ultrasound technique. That means they actually produces ultrasound which will actually travel from one point to another, and if there is any obstruction, the ray will get reflected back. Okay, so bat has the ability to understand, means they do have the capability to understand the ultras, means how they reflect back. If there is, by understanding the sound waves, they will be able to determine whether there is an obstacle in the way or is the prey nearer towards. Everything can be detected using that sound. Okay, and this has many wide applications. You will learn that in higher classes when ships are moving in sea. Beneath also we use sonar devices, radar devices, etc. are used to understand these kind of sounds which are being produced. Okay, and while earthquakes, the vibrations, all of these can be detected by this method. So we are only able to hear sounds which are under the audible limit, that is between 20 hertz to 20 kilohertz. Clear? Yeah, echolocation. True. Clear? Can we move on? The last topic, noise pollution. We listen to music, isn't it? It's very soothing, very, even I told you that when I'm very stressed out, I listen to music, I switch to music. So music, when it is arranged in a proper manner, it's very pleasing to us, isn't it? But noise is something which makes us irritated. Imagine that you're traveling on a road, okay, and we know that nook and corner there is traffic block, or sometime if there is any blockage in the toll, you are in the queue, and if every vehicle starts to put the horns, how will you feel? From every side you are hearing this horn side. At the same time you are hearing a helicopter moving above you. At the same time you are uh, means many, at the same time you are hearing something heavy falling down. So all of this, okay, you are right beside the highway, okay, so all of these sounds will be actually irritating you people, right? So this can cause headache. Some people, if not only all people, but we can also develop hypertension to it if we are hearing this kind of sound for a longer time, in a continuous manner. Our temper will also get changed. We will be very short tempered in such circumstances, as well as we, there is a chance to get hearing impairment also. It is not, it means it will not be lost completely. If that happens, that is a birth problem. That means it will be from birth. Means other than that, hearing impairment can also happen. Okay, so noise pollution is something which is not good at all. It actually affects adversely to our health. Not only to us, it affects the birds also, because birds won't be staying in a very noisy place. So all the, it is requested that all the residential, all the sounds made should have a limit on the residential area. So even if a function is being hosted, there is a limit of the sound which is being produced there. If it is going beyond that limit, then we can complain against them, and it's punishable. Okay, as well as for every vehicle there should be a silencer. For example, if it is for an aeroplane or if it's for a lorry, there should be a silencer. Otherwise the sound produced by them is much more. And the horns which were used later, that means earlier, is different from what we use right now. Okay, so that also will actually the whatever we are using an automated horn is different from the horn which we used in the earlier days. So that also actually reduces the noise pollution. So as well as we have to plant a lot of trees on roads, as means, as Sakshat says, if we are traveling on road and there are a lot of sounds coming up, if there were trees in between, these trees would have not absorb the sound, the intensity of the sound reaching us would have been very less. Okay, so we need to plant a lot of trees so that the sound reaching as, the intensity of the sound reaching as is very less. Clear? Is this much clear to you all? No, sound cannot. Sound requires a medium to travel. Any more questions? Okay. Actually, vacuum means it is an empty space. It doesn't have air at all. Okay. not even nothing will be there, no any sort of matter, nothing. It is an empty space that is actually known as vacuum. It is impossible to create vacuum. We have to evacuate the complete air from the surface, then only the vacuum will be created. But by experimental set, by now there are setups to do that. So vacuum can be created. So sound cannot travel through vacuum. Sound requires a medium for travel. Okay. Anything else? No, we can't. Wonderful. That's a good doubt. We can't. Okay. So this was our last session. We had wonderful time in the last 3 sessions. I had 2 more joiners today. So glad to see you all. I hope the class was helpful to you all. So hoping that we will meet soon again. Okay, I will miss you too. I'll miss you all. Okay, so even though I'm not scheduling any classes for you, I'm in touch with you all people because you all are there in our Manorama Horizons class. So we'll be in touch anytime. You can get back to me. Thank you. Bye. Good night. Have a nice day. Okay. Thank you, Devbala. Thank you. Thank you all. Oh, Gauri, you told. Okay. Everyone left. Oh, I missed to make you sing. Okay, we will do on next class. We will have some extra activities. We will have some refreshing time next time. I will miss you also. I will miss you all. Thank you. Bye.